I know you guys know all about triangles. Okay? I know that they have three sides. That's not a problem, right? I know that you know the names of them. So, acute triangle, those are the pretty ones, right? They have the small angles. Obtuse means it has one larger than what? 90 degrees. And a right triangle has a 90 degree. How many 90-degree angles? What about an obtuse? Can it have two obtuse angles? Can it have two angles larger than 90 degrees? No. Good. Now, equiangular. Sometimes those words are a little odd, but equiangular means that they have all the same angle. Is it possible to have a triangle with all three angles exactly the same? Okay. How many degrees would each one of those angles be? They would all three be acute, this is true, but what degree measure would they be? How many degrees are in a triangle? 180. So how many angles are there in a triangle? So 180 in 3, what would you do? 60. That's okay. Well, now you know. See? That's why we do these things. Okay. So, let's try this. If I take a look at these, which one of these is going to be an obtuse triangle? Which one? OMN what? I don't understand. Oh, triangle. Okay, I got to make sure that I write down triangle. But I'm not going to put down ONM. I'm going to put down MNO. Why? Alphabetic order. Yes, I know it's math, but we put things that we always like putting things in order, numerical order, alphabetic order, things like that. We like order. So, which one of these triangles would then be right? Yes, sir. Okay, so triangle, J, K, L. Easy enough, right? Okay. So my next question is, are any of these triangles, if I learn how to talk, equiangular? PQR has all three angles that are exactly the same? Really? You sure? Well, that's okay. What happens if I had two angles that were, say, 45 degrees? What would the other angle have to be? 90. So not all three angles would have to be the same, would they? Okay, so are any of these triangles equiangular? And the answer would be no. Okay. Now, if they'd had that little mark over in here, then the answer would have been yes. Okay. So, can we also identify them by the sides? So, an equilateral triangle would mean that all of the sides are the what? Same. An isosceles triangle would mean that how many sides are the same? Two? Just two? Any two? Okay. What about a scalene? 0. And again, you've seen these before, you've worked with these before, you've identified these before. So it's not all that different from what you have seen in the past, yes? No? Maybe? Good, I hope it's not different because that means they've mentioned the wrong things then. But if it's the same, that means I'm doing it right then, right? Yeah. So, here we go. Continuing on. So, I want to classify the triangles by sides. So, which one of these triangles could be scalene? GHJ what, huh? Triangle, there we go. Got to make sure we get that in there. So, we get triangle, GHJ. Now you'll notice that there's no I in there. Generally, I is one of those things that's reserved in mathematics for a specific thing, so you won't see that very often. It means an imaginary number. They give you a couple years and then we'll play with them. So, what about B? Are any of these triangles equilateral? ABC? Triangle ABC, yes, triangle ABC. Okay? So, now the next question is a bit of a puzzler for some people. Are any of the triangles isosceles but not equilateral? Which one? Triangle what? GEF? DEF. Okay? Is triangle ABC isosceles? Triangle ABC isn't isosceles? Well, yeah. So my question would be, let me phrase it this way. So if I'm looking at triangle ABC, are two sides the same? So does that mean it has to be isosceles? So if I got a triangle and I got two sides the same, it doesn't mean it's isosceles? Yeah, triangle ABC is triangle ABC isosceles. What do you mean could be? It either is or it isn't. It's either got two sides the same or it doesn't have two sides the same. Yeah, so what's your point? But it can't have two sides the same, right? So my question is, does triangle ABC have two sides that are the same? Yes. So is it isosceles? Good. Whew, glad we got that taken care of. Well, see, and that's part of the thing is these triangles can be classified in under more than one heading. So if it's isosceles, it doesn't mean it's equilateral, but if it's equilateral, it also means that it's isosceles. So it's something we need to keep in mind. Now, I think did I skip something? Oh. So these things you know, right? The vertex of a triangle is where two sides meet. In other words, the pointy part. The base of a triangle is what it sits on, right? Now, can I turn a triangle any way that I want and call that side the base? Okay. What about the height? Now, I'm going to tell you this much when it comes to the height. The height must always have something identified between the base and it. Always must have, always must have, always must have a 90-degree angle identified between the height and the base. If I don't have that, I can't say that one is the base and one is the height, okay? So if I know that, I got to have that right angle in there, otherwise this will not work. Okay. Now the thing is, I can turn these triangles around any way I want, and as long as I can measure the height, I'm fine. But I need to make sure that that's identified. So, with that thought in mind, you guys know this, right? Never seen it before? Generally, I think about it like this myself. So A is going to be equal to base multiplied by height divided by 2. Is generally the way I deal with it. Doesn't matter, you get to the same place, you know, one half of the base multiplied by the height. By the way, does the order of multiplication matter? Does 2 times 3 is the same as 3 times 2, right? So, how we go and do it really doesn't matter. That we have the correct formula, so we plug it in, we know what we're doing. A lot of people don't like dealing with fractions, do they? So that's why I take base times height divided by 2. Okay. So, if I move on to this, if I want to find the perimeter of something, that means I have to do what to it? Are you sure? Positive? Add what? What measurements? What sides? Okay, the sides of the triangle. Okay, so what's one of the sides of the triangle that add together, I should say? Okay, so I got 40.26 plus, what would be another one? 31.5 plus what? 12.5? Do I add the 10 in? Correct. The 10 is the height. That little dotted line, you got to be careful about it. It isn't part of the triangle. It's just identifying how far it is from the highest point to the lowest point. So if I add all of these up, I would end up getting 84.26, he says. Well, 0.5 and 0.5 add to 1, so that means 0.26 stays there. I got to add a 1 to the 1, so that makes it 2. 2 plus 2 is 4. 4, 3, and 1, well, that gives you 8. It's not that bad. But is that the correct answer? No. Oh, thank you. Do we always have to make sure that we label things? And we've got to label them appropriately. So if I want to take care of the area of this one, what gets multiplied by what? Okay, so what's the base? 31.5 times 10 divided by 2. So there's a lot of ways that I can think about this. I could take 31.5, multiply it by 10, and then cut it in half, right? I could take 2 into 10, get a 5, 5 times 31.5. All depends upon what you're looking at. So, somebody with a calculator out there, I'm sure, has got it done already. You got what? 155? You sure? Stake your life on that? It's an educated guess. Okay. Somebody want to check his math? You can't always just go and, assume that it's going to be that. Well, yeah, I'm not saying that you shouldn't. I'm not saying it's right, and I'm not saying it's wrong. I'm not saying anything. I'm saying that you should always check. What? Okay. What are you saying again, Storm? Multiply it with 3. There's only 2 numbers. 31.5 and 10. Come on, let's get off of that. Shh. Quiet down. So it's supposed to be what? Correct. 157 point what? And this centimeters squared. Trust but verify. That's the way you got to do it. So, what I want you to do is I am going to give you a minute, and I want you to do problems A through D. Do problems A through D. Which one of these is obtuse? Triangle. U, V, W. Everybody agree? Good. It's a good thing. Let's see, now we got Isaac is gone. We got 7 being Tara. So which one of these triangles is acute? Okay. So considering that Parker said that triangle UVW is obtuse, you've only got 2 triangles left. Okay. Y, Z, and X. You mean X, Y, and Z? But wouldn't you mean triangle X, Y, Z? Yeah. So we got to make sure that we say triangle X, Y, Z. Got to make sure that we put the triangle in there so we can identify what it is we're talking about. Okay. So, always helps from the right place here. Let's see. Cameron. So, which one of these is a right isosceles triangle? Triangle RST. You sound like you have a question with that. Oh, okay. Okay, so that's good. So, let's see. Who wants to have Isaac? Tessa. Are any of these triangles scalene? Absolutely correct. It is a yes or no question. Ah, but if she says that this would have to be, wouldn't you have to identify which one it is, not just say yes?
It says the triangle, so you can still be in the triangle.
Yes. Yes, XYZ is scalene. Well, they're technically right, but you're providing all of the information that's required. Yes, you have a more complete answer.
I have a more math answer.
Yes. Shh. Okay, guys, I'm going to give you a minute, and I want you to do E. Do E. Minute and do E. You got it all written out? So, let's see, that puts us now, we don't want to pick on Parker again. Christopher. Yeah, I know, but he's already answered the question. So, 45.1. Are you sure? Centimeters. So, if that's the case, it says 13.2 centimeters. And it says legs. Legs, when it's plural like that, it implies more than one, right? So does that mean that this side here is 13.2 and this is 13.2? Is that true? I mean, sure. Okay. Does that mean that this side here is the 18.7? Okay. So one of the things I'm going to tell you is when in doubt, draw it out. A picture is going to give you a better idea of what's going on in the problem. So, if I go and take that, and add them up, I get 45.1. There we go. So I'm going to give you a minute, and I want you to do problem F. Serena. You said what? 87.12 cm squared. Do we have agreement out there? Well, what's the base? Okay, base is 13.2. What is the height? Yep, 13.2. And then I have to divide it by what? 2. So, well, we'll just check this out with the calculator once here, and we shall see. So we clear this out. We get 13.2 times 13.2, divide it by 2, and I end up with 87.12. Absolutely correct. So, I'm going to give you a little time here, and I want you to do G. Do G. It is what it is. Ready? No. See who we got. Storm. It's because you need to make sure that you actually do instead of go around. So, but we got to deal with this. So, I need to find the perimeter, correct? Okay, so which numbers do I have to add up, Storm? The what? And what are the 3 outside numbers? Okay. And? Okay. So if I add all of those up, what do I end up with? Somebody got the answer out there? Parker, what do you got? 3,007. 3,007 yards. Okay. So I'll give you another minute, and I want you to take care of the last one down there, H. Ready? This one's almost too easy, isn't it? Let's see. It really lets pick on Parker today, doesn't it? Tie. There we go. So you didn't even bother attempting to write anything down or anything else. I'm sitting here watching you, so don't bother with that one.
I was doing
You gotta write it out. Oh, okay, so what multiplies by what to get the area? Okay, so give me the numbers that I'm supposed to multiply together. Okay, 603. Okay, by 1254. And then that gets divided by 2. So what did you get when you did that? 378,081, right? Now, is this what we're supposed to find? We're supposed to find 95% of that. So 95% is what? What do I got to do? Yep, multiply by 0.95. So when I multiply by 0.95, what do we end up with? Well, multiply by 0.95. 359,000 what? Okay. Do I still have the answer I'm looking for? Okay. Because the last thing is I got to round it to the nearest yard, so that's 359, comma 177, and this would be yards squared. So make sure that you take the time to go through and read it, and make sure you get all the bits and pieces. So there you go, and you can start work on the assignment.